Here is something that surprises almost everyone. Kubernetes never runs a bare container, not once. You asked it to keep 3 healthy copies running and it did. But 3 copies of what exactly? Not what you would guess. So today we open the box. Here is the surprise. Kubernetes never schedules a bare container. The smallest thing it will deploy, move or count is called a pod. Containers live inside pods always. Now, before you picture something complicated, most of the time a pod holds exactly one container. That is the ordinary case. If you mentally replace the word pod with the word container, you will be right most days. So why the extra wrapper? Because sometimes 2 containers genuinely belong together. A main application and a small helper beside it. Put them in one pod and they share a network address and can share storage. They behave like one unit because they are one unit. But do not get attached. A pod is cattle, not a pet. It can be replaced at any moment and its replacement gets a new name and a new address. Anything you want to keep, a database and upload, belongs in real storage, not inside the pod. So when you asked for 3 copies, you were asking for 3 pods. When one dies, a pod is replaced. When traffic grows, pods are added. The pod is the unit that everything else in Kubernetes counts. Pods have to run somewhere, and that somewhere is a node. A node is simply a machine, a physical server or a virtual one in a cloud. Nothing exotic. One node runs many pods. Put a group of those machines together, managed as one, and you have a cluster. That word sounds grand. It is just this: some machines plus something that decides what runs where. And that gives the cluster 2 halves. The control plane is the brain. It makes decisions and holds the truth. The worker nodes are the muscle. They run your actual pods. Every component you are about to meet lives in one half or the other. Start with the brain. Everything enters through one door, the API server. You talk to it. The components talk to it. Nothing bypasses it. If the cluster has a front desk, this is it. Behind that door is etcd, the cluster's memory. It stores the truth about what should exist and what does exist. Lose etcd and you have lost the cluster's mind, which is why people back it up carefully. Next, a new pod needs a home. The scheduler picks it. It looks at how much memory and CPU the pod asked for, which nodes have room, and any rules you set about where things may run. Then it assigns the pod to a node. That is its whole job. And the loop from last episode, it lives here too. Controllers watch desired against actual and act on the difference. Reconciliation is not one program. It is a family of controllers, each minding its own kind of thing. Now the muscle. On every worker node, there is an agent called the kubelet. It asks the API server what it should be running, makes sure those pods are actually alive, and reports back. Think of it as the foreman on that machine. But the kubelet does not start containers itself. It asks a container runtime to do it, usually containerd or CRIO. And here is a fact that surprises people. Modern Kubernetes does not need Docker engine on your nodes. It talks to any compatible runtime through a standard interface. So let's watch one request travel the whole cluster. You run kubectl apply. It reaches the API server, which validates it and writes it into etcd. The scheduler notices a pod with no home and picks a node. The kubelet on that node sees the assignment, asks the runtime for the containers, and the pod starts running. Then the kubelet reports back and etcd is updated. That is the entire path. And the beautiful part is that failure uses the same road. A node dies, its pods stop reporting. A controller sees the gap, asks for replacements, the scheduler places them on healthy nodes, and those kubelets start them. No new machinery, the same loop doing its job. Now, how much of this do you operate by hand? Almost none of it. You talk to the API server, usually through kubectl or a file. The scheduler, controllers, kubelets and runtimes are doing their work whether or not you are thinking about them. So please do not memorize these names for their own sake. Hold one sentence instead. You tell the front door what you want, the brain decides where it goes, and an agent on each machine makes it real. 3 things to keep. Kubernetes schedules pods and containers live inside them. A cluster is machines plus a brain that decides, and every request, success or failure walks the same path through that brain. Next time we put it to work, deployments that keep the count and services that give your pods one stable address. See you there.